15 billion miles from Earth, a machine older than most of your parents just sent back a signal that made NASA's own scientists stop and stare at their screens in confusion. This is not science fiction. This actually happened. And nearly 4 years later, some of the world's top space scientists still cannot fully agree on what caused it. We are talking about Voyager 1, the most distant human-made object in existence, a spacecraft that has been flying through the darkness of space since 1977. If you think that sounds impossibly old for a piece of technology to still be working, you are right to be amazed, because what this ancient probe, just detected out past the edge of our solar system, has left researchers questioning things they thought they had already figured out. Stick around, because this is one of those stories where the deeper you dig, the stranger it gets. Let's set the scene properly first. Voyager 1 launched in the summer of 1977 originally, built to fly past Jupiter and Saturn and send back the first detailed pictures of those planets. It did exactly that, and by all accounts its main mission was already a total success decades ago. But instead of shutting down, the little spacecraft kept going and going and going. Today, it is more than 15 billion miles from Earth, so far away that a radio message sent from mission control takes over 22 hours just to reach it, and another 22 hours for a reply to come back. By November of 2026, that gap is expected to stretch to a full Voyager 1 will officially become one entire light day away from home. In 2012, Voyager 1 did something no human-made object had ever done before. It crossed the heliopause, the invisible boundary where the sun's constant stream of charged particles, known as the solar wind, finally gives way to the vast emptiness of interstellar space. In simple terms, it left the neighborhood of our solar system entirely and became the first spacecraft to fly through true interstellar space. That alone would be a remarkable enough story on its own. But what happened next is where things start to get genuinely puzzling. Scientists expected a very specific thing to happen the moment Voyager 1 crossed into interstellar space. They believed the direction of the magnetic field around the spacecraft would suddenly and dramatically shift, almost like flipping a switch, marking a clean and obvious line between the sun's territory and the rest of the galaxy. Instead, something completely unexpected showed up in the data. The magnetic field barely changed direction at all. One of the scientists working on the magnetometer instrument later admitted that this result genuinely shocked the entire team, because nobody had predicted that a spacecraft could leave a river of solar particles for an entire ocean of interstellar plasma without any dramatic shift in its magnetic surroundings. If a detail like that is already making you raise an eyebrow, wait until you hear what came next. Researchers eventually found that the true confirmation Voyager 1 had left the solar system did not come from the magnetic field at all. It came from a sudden increase in something called plasma density, essentially a thicker soup of electrically charged particles that exists beyond the reach of the sun's protective bubble. That part of the mystery, at least, scientists were eventually able to explain. But another piece of the puzzle remained stubbornly unsolved for years afterward. The direction of that magnetic field was tilted a full 40 degrees away from what scientists expected to see once the spacecraft was truly free of the sun's influence. For nearly a decade, that 40-degree deviation puzzled some of the most experienced researchers in the field. It eventually took a team from the University of New Hampshire, combining data from 4 completely different spacecraft, to piece together a workable explanation. According to their research, the magnetic field around Voyager 1 is being stretched and pushed by the pressure of the solar wind, almost like a rubber band wrapped around a beach ball and pulled out of shape as it stretches around the edge. Even with that explanation, the team predicted it could take another full decade before Voyager 1 finally reaches a region of space where the surrounding magnetic field is no longer influenced by the sun at all. Quick pause here. If you are the kind of person who finds this stuff genuinely fascinating, go ahead and tap that like button right now. It costs nothing, and it helps this channel keep making videos exactly like this one. Now here is where the story gets even more unusual, because the magnetic field puzzle was really only the beginning. In May of 2021, NASA quietly announced something remarkable. Voyager 1's plasma wave instrument, the same tool designed to detect vibrations from charged particles drifting through space, picked up a faint, continuous humming sound coming from the interstellar medium surrounding the spacecraft. This was not a random burst of noise. It was a steady, persistent signal, essentially the sound of interstellar space itself, vibrating with extremely low-density plasma, something scientists had never been able to listen to directly before Voyager 1 made it out that far. That discovery alone reshaped how researchers think about the region just beyond our solar system. But then, in 2020, something stranger started happening. Voyager 1's magnetometer picked up a sudden, sharp jump in the intensity of the magnetic field surrounding the spacecraft. Detector recorded an unexpected rise in plasma density. On its own, this would not have been shocking. Scientists had actually seen similar spikes before, and they had a solid explanation ready. These jumps were believed to be caused by powerful surges of solar wind slamming into the outer edge of the heliosphere, sending ripples out through interstellar space that briefly compressed the plasma and intensified the surrounding magnetic field, almost like a piston pushing outward from deep inside the solar system. Here is the part that genuinely stumped researchers, though. Those earlier anomalies always faded back down to normal levels after a few months. This time, the elevated readings did not go away. They simply continued month after month, refusing to settle back down to what scientists considered a normal baseline. That single detail was enough to make some members of the mission team seriously question whether the piston explanation was even correct anymore. If solar surges were really the cause, the readings should have eventually calmed down the same way they always had before. Instead, Voyager 1 kept reporting numbers that stayed persistently high, almost as if something entirely different was now surrounding the spacecraft. One leading theory being seriously discussed among mission scientists is almost as strange as the anomaly itself. Some researchers now believe Voyager 1 may have drifted into a small, isolated cloud of ancient interstellar plasma, a pocket of material left over from a star that may have exploded long before our own solar system even existed. If that theory holds up, it would mean the elevated magnetic field readings are not caused by anything coming from our sun at all, but instead by leftover material from a completely different long-dead star system, something humanity has never had the chance to measure directly until now. Think about that for a second. A machine built using 1970s technology, with less computing power than the calculator app on your phone, may have just stumbled into the physical remains of another star's death, drifting silently through the galaxy for who knows how many millions of years before Voyager 1 happened to fly straight through it. Of course, none of this comes without real-world challenges back here on Earth. Voyager 1 is now so old that its power source, a radioactive generator that has been slowly decaying since launch, produces less electricity every single year. To keep the spacecraft alive and still transmitting data, NASA engineers have had to make difficult decisions, shutting down one instrument after another to conserve the little power that remains. The spacecraft has also experienced serious technical problems in recent years, including a memory chip failure in 2023 that caused Voyager 1 to send back nothing but garbled, meaningless data for nearly 5 months. Engineers eventually solved that problem by rewriting the affected code and relocating it to a different section of the spacecraft's aging memory, an incredibly delicate repair job performed on a computer system floating more than 15 billion miles away, using nothing but slow, patient radio commands sent across the void. If you're new here and this kind of deep space mystery is exactly your thing, now would be a great time to hit subscribe, because there's a lot more of this waiting for you. What makes all of this even more remarkable is the timing. Voyager 1 was never designed to still be operating decades after launch, let alone to still be making genuinely new scientific discoveries at the edge of interstellar space. Its twin spacecraft, Voyager 2, entered interstellar space of its own in November of 2018, roughly 6 years after its sibling, and continues to operate normally, giving scientists a second set of every new anomaly Voyager sends back forces scientists to rethink assumptions that nobody fully modeled in advance. One space scientist working on these findings summed it up simply, pointing out that boundaries remaining power for as long as physically possible, hoping to keep at least semi-new signal that comes back, however faint or strange, gets carefully studied by teams of scientists trying to understand a region of space that no human has ever visited and no other spacecraft has ever explored in this kind of detail. As Voyager 1 continues its slow drift outward, there is a real possibility it could encounter even more of these strange, unexplained pockets of ancient interstellar material, each one carrying its own set of secrets about what actually exists in the vast emptiness between stars. For now, the mystery remains open. Scientists have their leading theories, and the ancient interstellar cloud idea remains one of the most compelling explanations currently on the table, but nobody is claiming to have the final answer yet. What we do know is that a nearly 50-year-old spacecraft, built before most currently working NASA engineers were even born, is still teaching us new things about the universe, one strange signal at a time. There is something almost poetic about the whole situation if you stop to really think about it. Back in 1977, when Voyager 1 first launched, the engineers who built it could not have possibly imagined the spacecraft would still be transmitting data nearly 50 years later, let alone from a region of space that did not even have an official name at the time. Interstellar space, for most of human history, existed only in theory and imagination. Nobody had a spacecraft capable of actually reaching it, let alone one that could keep working long enough to report back what it found. Voyager 1 changed that completely, turning a distant theoretical boundary into a real place with measurable properties, strange signals, and now, apparently, pockets of ancient stellar debris drifting silently through the dark. It also raises a bigger question that scientists are only beginning to seriously explore. If Voyager 1 really has drifted into a small cloud of leftover material from a long dead star, how many more of these hidden pockets might be scattered throughout our local region of the galaxy? Interstellar space was once assumed to be almost perfectly uniform, a thin, mostly empty medium spread evenly across vast distances. But if Voyager's data holds up, that assumption might be wrong. The space between stars could be far lumpier and more complex than anyone previously thought, filled with invisible remnants from ancient stellar explosions that we have simply never had the tools to detect until now. This is exactly why scientists are so reluctant to declare a final answer just yet. Space. Research rarely moves in straight lines. A single spacecraft sending back a handful of unusual readings from 15 billion miles away is not enough on its own to rewrite the textbooks. Researchers need more data, more time, and ideally, confirmation from other instruments before they are willing to commit fully to any one explanation. That patient, careful process is not always as exciting as a dramatic headline, but it is exactly how real scientific discoveries eventually get confirmed or ruled out. Meanwhile, back on Earth, the team behind Voyager 1 keeps doing what they have done for nearly 5 decades now, carefully listening to a faint, distant signal crossing unimaginable distances, decoding it, and trying to make sense of a place none of us will ever get to visit ourselves. Every single command sent to the spacecraft has to be planned with extreme precision because there is no room for mistakes when a signal takes almost an entire day just to arrive. A simple typo or miscalculation could mean losing contact with humanity's most distant emissary permanently, with no way to fix the problem quickly, given the sheer distance involved. And honestly, that might be the most incredible part of this entire story. Voyager 1 was never supposed to make it this far. It was never supposed to still be operating, let alone still be capable of surprising the very scientists who built it. Yet here it is, 15 billion miles from home, quietly sending back data that keeps rewriting what we thought we understood about the edge of our solar system and the strange, silent ocean of space that lies beyond it. If this story kept you hooked until the very end, make sure you are subscribed with notifications turned on, because Voyager is still out there right now, still listening, still transmitting, and there is a very good chance the next strange signal it sends back could be even harder to explain than this one.